Good morning, sixth grade. Hopefully everybody had a great weekend. Last week we finished up chapter 10 and today we're moving on to chapter 11. So let's figure out where that material is at. So if you go in here to Google Classroom, click on classwork, scroll down here to chapter 11, click on that. And here we are here, chapter 11, lesson 1, completed notes. You can click on that and follow along. So let's talk about what we're going to be doing today. Today, chapter 11, lesson 1, angle and line relation. So we're going to be looking at geometry. In geometry, there's a lot of the symbols you must understand the meanings behind. So we're going to be going over a lot of that from chapter to chapter. But first, we're going to begin with what are known as pairs of angles. So we're dealing with pairs. We're dealing with two angles and what type of a relationship do they have. So let's look here first at the vertical angle. So it says when two lines intersect. What we mean by that, we have a line here and a line here. It's a terrible drawing here, but they intersect. Okay, they intersect at this point right here. So it says when two lines intersect, they form two pair of opposite angles. Okay, these are called vertical angles. So that means this angle is formed and the opposite of angle 4 is angle 3. If we look at here, the opposite of angle 1 is angle 2. Okay, those are opposite angles. Those are known as vertical angles. And let's see what that means. Vertical angles are congruent. The word congruent means equal to. So you need to understand that. The word congruent is equal to. And the symbol we use for congruent in geometry looks like this. We have our equal sign with a tilde over top. Okay, this squiggle here. That means that the angles or measurements are congruent, which means they are equal to. So if we take a look here, it says angle 1 is congruent to angle 2. Do you see the angle symbol we have here? Okay, that's one of the symbols you need to understand. This angle means that, hey, we're dealing with an angle. So angle 1, this angle here, is congruent to angle 2, which means they are equal to each other. And we also know that angle 4 is congruent to angle 3. That's what we have right here. So that means they are equal to, which means their measurements are the same. So basically what we're saying here is if angle 4 was 65 degrees, angle 3 would be 65 degrees. Let's just say that angle 1 was 115 degrees. That makes angle 2 115 degrees. So which means they are equal. They are vertical angles. So let's continue on down here. Let's talk about adjacent angles. Two angles that have the same vertex between them. So if we look here, this is the vertex here. Okay. The vertex is right here in this area here. They share this point here. Okay. Share a common side. Well, here's the side that angle 5 and angle 6 share. Okay. And do not overlap are called adjacent angles. So these angles here do not interlap. So you have 5, which is right here. That's a terrible angle. And then we have angle 6, which is right here. Now they're not supposed to overlap at all. So we know that angle 5 and angle 6 are adjacent. That does not mean they are congruent. It just means they are adjacent. They share a same side here. This side right here. They share together. Okay, let's look at complementary. If the sum of the measure of two angles here, okay, is 90 degrees, you need to understand that. Complementary means 90 degrees. Two angles added up together that equal 90 degrees, then they are complementary. So as you look here, angle 7, okay, plus angle 8. When you add those two angles together here, they should equal 90 degrees. People have asked, what does this M mean here? This M means the measurement. The measurement of angle 7 plus the measurement of angle 8 must equal 90 degrees. Supplementary. Well, if complementary is 90 degrees, then supplementary is going to be 180 degrees. So let's look here. If the sum of the measure of two angles is 180 degrees, the angles are supplementary. Okay, so this angle 9 plus this measurement of angle 10, when added together, equal 180 degrees. So what we would say here is the measurement of angle 9 plus the measurement of angle 10 equals 180 degrees. Now, some people get confused by this. They go, okay, how do I remember supplementary and complementary and what they equal? Well, some people say, hey, look at the letter C in the word complementary. With one line, if I draw a straight line down off the C, that looks like a 9. So that is 90 degrees. If we look at supplementary, if I draw an S, right here, there's an S. With one line, I connect the endpoints and it gives me an 8. So there's my 180 degrees. Other people say, hey, complementary, C comes before S. So complementary comes before supplementary. 90 comes before 180. So that's one way to remember those two measurements when you're dealing with complementary and supplementary. So let's continue on down here. Let's see what we have. It says down here, pairs of angles can be classified by their relationship to each other. A special case occurs when two lines intersect to form right angles. These lines are perpendicular lines. Okay, so let's look here at a couple things here. It says a right angle symbol is used to indicate perpendicular lines. You see this little square here in the corner here. That square right there means, hey, this is a right angle. Now think about this. If this is a right angle here and this forms a straight line, does everybody know how many degrees are in a straight line? 180 degrees. So guess what? If this is a right angle, guess what this angle is over here? That is a right angle also. And they are supplementary. This angle and this angle are supplementary because they both add up to be 180 degrees. Let's look over here. What do you think this angle is here? It is a right angle also. So this angle plus this angle equals this straight line, which we know in a straight angle or a straight line, that's equal to 180 degrees. Which finally, we would say, hey, this angle right here is 90 degrees also. And we could also say, hey, you know what? This angle here, I'll shade it in blue a little bit, this angle here and this angle here, they are vertical angles. So if this is 90 degrees, this is 90 degrees here. They are vertical angles. Now, let's talk about our symbol for perpendicular lines. You see this upside down T here? That means they are perpendicular, which means the angles are 90 degrees. Now, some of you are saying, well, Mr. Spencer, what is this right here? That's a cursive L. We don't want to use an L that looks like that, okay? Because it looks like a number 1. So typically when we're dealing with lines, they are in some type of a script, okay? So this is a cursive L, a cursive M. So that's how we identify our lines. So if we look here, if we're saying line M is perpendicular, we use the upside down T, to line M, which means all the angles are 90 degrees. So let's move on down here. Okay, June is cutting corners off a piece of rectangular tile. Classify the relationship between angle X and angle Y. Well, what we're looking at here is this angle right here. And we're saying, okay, what type of relationship does it have to this angle right here, the X and the Y? Well, as you see, if we put them together and add them together, they're going to form a straight line. And we know a straight line is 180 degrees. So we know that angle X and angle Y are supplementary angles. So it says, find the measurement of if the measurement of angle Y is 135 degrees, so this is 135 degrees, okay? What's the measurement of angle X? Well, we know this these two angles together form a straight line, which is 180 degrees. So we know that angle X, the measurement of angle X plus the measurement of angle Y equals 180 degrees. Well, we know what Y is. We know Y is 135 degrees. So if I take the measurement of angle X plus 135 degrees equals 180 degrees. So in order to solve this, I've got to get the 135 to the other side over here. So in order to do that, the 135 is being added. The opposite of adding is subtracting. So I'm going to subtract 135 on both sides. So when I do that on both sides, I get the measurement of angle X equals 45 degrees. Do not forget your degrees. That's important to have. Let's look over here. Juan is cutting another towel. Classify the relationship between angle A and angle B. So if we look here, here's our A and here's our B. Okay, so if we look at those, they look like they're going to form a right angle. And when we're dealing with a right angle with two angles, we're dealing with complementary angles. Okay, so let's take a look here. It says, if the measurement of angle A is 53 degrees, so this here is 53 degrees, we want to figure out what angle B is. Well, we know the measurement of angle A plus the measurement of angle B equals 90 degrees because they are complementary. So I take angle A, which is 53 degrees, plus the measurement of angle B, which we don't know, and set it equal to 90. Well, this is a positive 53 degrees. I'm going to subtract 53 degrees on both sides, due to both sides. So the measurement of angle B is 90 minus 53 degrees. So we get the measurement of angle B to be 37 degrees. Okay, very good so far. Let's scroll down here to parallel lines. Now, as you see here, here is the symbol for parallel lines right here. Okay, two lines beside each other showing that they are parallel. Now it says two lines in a plane that never intersect are called parallel lines. Okay, a line that intersects two or more lines in a plane is called a transversal. This line here is our transversal. It is intersecting line S and line T. Okay, so this here, I believe we are calling line V. Okay, so this transversal line V is intersecting lines S and lines T. Okay, so just to show you this here, there's a couple of things here. It says lines S and T are parallel. Well, that's what we are given. So the symbol we would use, we'd say S is parallel to T. Okay, line S is parallel to T. Now, you also see these arrows here. This arrow and this arrow here that are sort of in the middle of these lines. If you see these arrows that look like this also will tell us that line S is parallel to line T. We use those arrowheads to indicate that these lines are parallel also. And of course, this line V is our transversal. It says, when parallel lines cut by a transversal, special pairs of angles are congruent. Okay, so now what we're looking at here is when I have a set of parallel lines, S and T, and they're cut by a transversal, we have special congruent our angles here. And that's what we're going to be looking at down here. You're going to have to know these different vocabulary terms. They are very easy, but you have to understand them. It says, when a transversal intersects two parallel lines, 8 angles are formed. So as you see here, we got 1, 2, 3, 4, 5, 6, 7, 8. There's 8 angles here. It says interior angles lie inside the parallel lines. So here's our parallel lines here. Okay. And what angles lie inside, mean in between these lines here? So as you see, angle 3, angle 4, angle 5, and angle 6 are known as our interior angles here. Now, we have also what are known as our exterior angles. They're the ones that are outside, the ones up here, the ones down here. These are the angles that are exterior. They're not inside the parallel line. So these are angles 1, 2, 7, and 8. Those are exterior angles there. So let's see what we have here now. So it says, the following pairs of angles are congruent, which means they are equal to each other. So we have what are called alternate interior angles. Okay, so let's take a look at this vocabulary first. Alternate, think of the word alternate, okay? It goes on each side of the transversal. Now remember, L here is our transversal. This line here that goes all the way through these parallel lines, this is our transversal here. Alternate interior angles, okay, are on opposite sides of the transversal. Okay, so you cannot have them on the same side as the transversal. They have to be opposite sides of the transversal and inside the parallel line. So what we're saying here is this. Look here at angle 3. Angle 3 is congruent to angle 5 because they are alternate. They alternate across the transversal here and here. They alternate across. And they are interior, which means they are inside the parallel lines. So angle 3 is congruent to angle 5, and we would say they because of alternate interior angles. You can see right here, angle 3 is congruent to angle 5. Now let's look at angles 4 and 6. Angle 4 is congruent to angle 6 because they alternate across the transversal, and they are interior. They are alternate interior angles also, which means they are congruent. Okay, let's look at the next ones. We've got the alternate exterior angles. Okay, alternate exterior angles are on opposite sides of the transversal and outside the parallel line. So let's start here with angle 1. Here's angle 1. Okay, it's an exterior angle because it's not inside the parallel line, so it's an exterior angle. And which one alternates across the transversal? That's also on the it's also an exterior one. That would be 7 here. Okay, as you see, they sort of go on a diagonal. That means that angle 1 is congruent with angle 7 there. Let's move on here to angle 2. Angle 2 is going to be congruent to angle 8, okay? Because they are exterior and they alternate across the transversal, so they are congruent also. So angle 2 is congruent to angle 8. So we have those. Now, let's look at what we have here with corresponding. Corresponding angles are in the same position on the parallel lines in relation to the transversal. That's a lot of information. Basically, what we're saying here, one is inside and one is outside the parallel lines, okay? And one is hooked to one line and one is hooked to the other line. So let's take a look here. Let's look here at angle 1. I have angle 1 here, okay? That is an exterior angle on line J here. Well, let's go with an interior one on the same side as a transversal, but is now inside. Look at 5. 5 is right here. So angle 1 and angle 5 are congruent also. We call those corresponding angles. Well, let's look at some other ones here. Well, 2 and 6 are corresponding angles also. We also have some other ones here. We also have 4, here I started on the inside, and also 8. Those are corresponding angles also. And then finally, we have angle 3 and angle 7 are corresponding angles also, okay? One is inside, one is outside, and they're hooked to 2 different lines, okay? So you need to make sure you memorize these terms here. Your alternate interior angles, alternate exterior angles, and corresponding. And you should also remember here, angle 2 and 4 are congruent because they are vertical angles. 6 and 8 are congruent because they are vertical angles. 3 and 1 are congruent because they are vertical angles. And 5 and 7 are congruent because they are vertical angles. If we were to look at some of the other ones, 1 and 2, those are supplementary. 3 and 4 are supplementary. 1 and 4 are supplementary. 2 and 3 are supplementary, and so on and so forth. You can see here with 5 and 6, 5 and 8, 6 and 7, and 7 and 8. Those are all supplementary also. So here we go. Let's continue down here and practice some. Okay, it says here in the figure at the right, line A is parallel to B. So we know that this line here, line A, that goes all the way through here, and line B are parallel. And you also see these triangles here showing that these two lines are parallel. Okay, so now we're saying, hey, this line here then must be a transversal. So let's see, let me move myself down here, and that's line Q. Okay, line Q is a transversal, and line R is a transversal also. So they want us to classify the relationship between angle 3 and 5. Well, let's find 3. Here's 3 here, and here's 5 here. Okay, A and B are our parallel lines. So if you go back up above, you can say, okay, how do we classify these? Since these are parallel lines, that means, hey, 3 and 5 are going to be congruent because of alternate interior angles over here. They're alternate interior angles. So angle 3 is congruent to angle 5. So let's look here now. Okay. It says, hey, if the measure of angle 1, here's angle 1 is 120 degrees. Okay. So if we say, hey, that's 120 degrees. Find the measurement of angle 5. Angle 5. Well, let's look here. There's several ways we could do this. Okay. We can say, hey, this is angle 1 and this is angle 5. They are on the same side as the transversal, but one is inside, one is outside. Hey, those are corresponding angles. So we could say, hey, find the measure of angle 5. I know the measurement of angle 5 can be 120 degrees. Now, there's also other ways we can do this too. We could say, hey, what if angle 1 is 120 degrees, that makes angle what? And angle 3 what? That makes it 120 degrees also, because those are vertical angles. So if 3 is also congruent to 5 because of alternate interior angles, that would also make 5 120 degrees. So there's several ways to go about this. The easiest way is say, hey, 1 and 5 are corresponding, which means they are congruent. So if the measure of angle 1 is 120 degrees, then the measure of angle 5 is 120 degrees. Okay, let's look more down here. Says classify the relationship between 9 and 13. Well, let's look here at 9 and 13. So here's 9. Here's 13. Once again, one is outside, one's inside, same side as a transversal. Those are corresponding angles right there. So we know those are corresponding angles. So we know that angle 9 is congruent to angle 13. Let's look down here below now. It says, if the measure of angle 13 is 75 degrees, so if this is 75 degrees here, 75 here, okay, find the measurement of angle 11 and the measurement of angle 15. Well, let's start with 11 first. 11, 13, and 11, okay? They're running off of parallel lines. Ours are transversal. Since we have 11 and 13, they're both inside. They are interior, our angles, and they cross the transversal. So those have to be alternate interior angles. So we know that 11 and 13 are alternate interior angles. So 11 has to be 75 also. Now, they also want to know, hey, what about 15? Let's look here at 15 here. If 13 is 75 degrees, 15 has to be 75 degrees also, because they are vertical angles. So you can say, hey, I know that angle 15 is 75 degrees also. So that means, hey, they are congruent. If you wanted to work you're backwards here, you can go say, hey, 15 and 11 here, they're corresponding and they are congruent also, which makes 11 75 also. So there's several ways to go about this. Okay, let's continue on down here. Let's see what else we have here. We've got some algebra now. Oh, I know you are excited about this. So let's take a look here. In the figure at the right, the measurement of angle ABD equals 164 degrees. So that means from this ray all the way over to this ray here, BD, this angle here is 164 degrees. Okay, that's 164 degrees. So they want us to figure out the measurements of angle ABC and CBD. Well, as we said, this angle here is 164 degrees. So if we think about that, this angle here, okay, this angle here, which is 2x plus 23, plus x has to equal 164 degrees. So if we write our equation here, 2x plus 23 plus x equals 164 degrees. So let's solve this equation right here. So 2x plus x equals 3x. So I now have 3x plus 23 equals 164. So I've got to get this 23 over to this side here. It's a plus 23. So the opposite of adding 23 is subtracting 23. So I'm going to subtract 23 on both sides. So I get 3x equals 141. So what's happening between the 3 and the x? It's being multiplied. Opposite of multiplication is division. So I'm going to divide both sides by 3 on both sides, and x equals 47. Now, that does not mean we are done. We know that x equals 47. So we know that angle CBD, because that's x, we know that's going to be 47 degrees. But we have to figure out what angle ABC is. In order to do that, we take this 47 degrees and we plug it into the x. So we go 2 times 47 plus 23 is going to equal 117 degrees. So that's how we get the measure of angle ABC is 117 degrees. The measure of angle CBD is 47 degrees. Okay, last one here. Let's see what we have here. Oh, I see a key term here. Key term here looks to be complementary. So it says angles DEF and WXY are complementary. Remember, complementary means they add up to be 90 degrees. With measurement angle DEF equals 2x and the measurement of angle WXY equals 3x minus 20. So if we look here, they want us to find out the value of x. Well, I know that DEF is 2x. I know that angle WXY is 3x minus 20. That equals our 90 degrees. So combine our like terms. 2x plus 3x is 5x minus our 20. I've got to get the 20 to the other side. So I do the opposite of subtracting 20. I add 20 to both sides. So I get 5x equals 110. Divide both sides by 5 here. And we get x to equal 22 degrees. So we know x is 22 degrees. So then down here, they're saying, okay, if you know that x is 22 degrees, what is the measure of WXY? So we know it's 22 degrees. So in the measurement of WXY is 3x minus 20. All we do is we plug in the 22 for x. So 3 times 22 is your 66 minus your 20 is 46 degrees. So the measure of angles WXY is 46 degrees, and you go from there. So hopefully you guys understood. There's a lot of information, a lot of the symbols you need to really understand. So make sure if you're unsure about some of the information, you go back and rewatch the video or parts of the video. Other than that, guys, have a great day.